Thank you, Monica. Can you all hear and see me? I just wait for some reactions. Okay, that looks good. Okay, welcome to our on-site audience here in Cologne, and of course to our international online audience. The weather in Cologne is quite beautiful today, so it's a pity that you can't be here with us. I'll try to reflect this in a sunny presentation. So let me see whether this works. Okay, I would like to start by situating the didactic use of Corpora within overall translation studies. As Monica already mentioned in her introduction, Silvia Bernardini and her colleagues, they say that this forms part of applied corpus-based translation studies. So if we look at the Holmes Turry map of translation studies, we're concerned with the applied branch, and here particularly with the field of translator training, where Corpora can be employed as learning resources, but also Corpora can also be used as translation aids in their own right, and this will be highlighted in the, or this is highlighted in the situated translation course that will be discussed later in this presentation. First, some general benefits of corpus use in translator training. I draw here primarily on Rodriguez Ines 2009. Firstly, corpus use, it reduces the role of the teacher's intuition in the translation classroom, and in this case more importance is assigned to the students and their documentation skills. Secondly, the role of the teacher can be shifted from information provider to information facilitator. In this case, the teacher would develop the procedural knowledge of the students in order to enable them to gain to build up declarative knowledge in a more autonomous way. And thirdly, the teacher can be relieved from being the sole source of authority in the translation classroom. And this authority can, at least in part, be assigned to the Corpora, which means that, for example, we can show our students that the translation solutions we consider to be suitable or of high quality, these are not derived from our personal tastes, but that there's empirical evidence that these solutions are suitable or of high quality, because you can find them in high quality translation Corpora. There are two major approaches to the use of Corpora in translator training, which are discussed in Bibi et al. 2009. The first would be corpus use for learning to translate. Within this approach, it is the teacher who is responsible for corpus compilation and corpus control. The teacher would provide the students with pre-selected data and then guide their analysis of this data. And the teacher's corpus would usually be tailored to a specific translation task that the students have to complete. This is a rather microscopic approach where the corpus is used as, and I quote Varantola 2003, as a performance enhancing tool which can be queried in order to solve specific translation problems. The second approach is called learning corpus use to translate. In this approach, the students have to compile a corpus themselves before they can use it to solve translation problems. And this is the more macroscopic approach of the two. The focus here is on translation-related issues of corpus compilation, such as corpus design, quality assessment, search strategies, etc. The epistemic value or the didactic relevance of specific corpus types, I chose only two here. The first being monolingual comparable corpora, which I think can also be termed parallel text corpora, because this is what they contain in the first place, parallel text to be used for specific translation tasks. There you can find linguistic information such as idiomatic use of terms and collocates, syntactic constructions, genre conventions, etc., but also conceptual information such as explanatory contexts for concepts of particular domains, and of course bilingual parallel, or as they are also called, translation corpora, containing source and target language texts. These corpora offer insights into strategies employed by, well, in the ideal case, by professional translators. They offer more collocational or stylistic information than bilingual dictionaries, and so on. And particularly when you're working with translation corpora, you have to make sure that the quality of the translation is adequate. I'll come back to this later in the talk. Briefly, some words on corpus use as a translational subcompetence. It is claimed more and more often that corpus use is no mere additional qualification to be acquired in addition to what you could call pure translation competence, but that, as Rodriguez-Ines claims, corpus use should be regarded as part of the wider translation competence itself. Now, Sylvia talked already extensively about the EMT translation competence model, so I thought I'd focus here on the PACTE model, where corpus use would form part of the instrumental subcompetence, which covers, and I quote PACTE 2003, procedural knowledge related to the use of documentation sources and information and communication technology applied to translation. Now, within this instrumental subcompetence, Rodriguez-Ines proposed a corpus subcompetence, which would cover, and I quote, the ability to use electronic corpora adequately to solve translation problems in an adequate manner. And this corpus subcompetence, I won't go into detail here, it covers the 4 elements listed below. Now some words on the situated translation course, in which we introduce our students to the use of corpora in a translation context. The course title is Translation Project Using Translation Tools. It runs 2 hours a week over a full semester, is taught in a classroom featuring state-of-the-art computers and software, and it is taught by a colleague of mine and myself. It forms part of the tools module of the MA in specialized translation, which we offer here at our university. And we like to refer to this course as an in vivo translation course, which attempts to project into the translation classroom as closely as possible the professional environment that students will encounter in their later careers as translators. The aim of this course is to enable students to complete complex translation projects using translation software and related tools, such as translation memory systems, terminology management software, and so on. The course is based on the theoretical framework of situated translation developed by Risku. 2004 is one of her major publications. The central claim, or one of the central claims of situated translation, is that translation competence is based on the situated development of intelligent solutions for particular problems arising in specific situations. And situated translation places particular emphasis on artifacts such as computers, software tools, the internet, etc. And situated translation claims that these artifacts have to be factored in when describing or developing intelligent human actions such as translation. Risku gives a good description of this. She claims that what happens in the minds of translators, which is the famous dictum by Krings 1986, what happens in the minds of translators must be complemented by an investigation of what happens in the hands, in the computer, or on the desk of translators. And I think this is a good description of the central tenets of situated translation. The didactic framework, we based this course on Göpferich's translation competence model because we think that it covers the relevant subcompetences required to perform successfully in professional translation. I won't discuss this model here in detail. Our course develops the different competencies of this model to different degrees, and in this presentation I will focus on the tools and research competence of this model, which covers knowledge or skills related to translation-specific conventional or electronic tools, for example text processing software, TM systems, terminology management systems, and also corpora. Now, the in vivo approach of our course requires us to assess whether the tools or processes available to translators, whether they're applicable in professional contexts, which are usually characterized by time and financial constraints, simply because the construction and consultation of corpora is quite time consuming. And this brings us to one of the problems of corpus use in in translation in general, meaning the discrepancy between the increasing use of corpora in translation teaching and the relatively low acceptance of this resource among professional translators. In this context, Aston claims that corpus use is, and I quote, anti-economic in the short term. Now, we took this as a justification for focusing on so-called do-it-yourself or DIY corpora in our translation course. These corpora are compiled for the specific purpose of completing a particular translation task. Other designations of these corpora would be ad hoc corpora, disposable, virtual, or ephemeral corpora, although they can be quite stable. So I think the designation DIY or virtual or ad hoc corpora describes these resources best. And they're useful not only as a training resource, but also as a resource to be used by professional translators. These corpora, they tend to be very precise, and they can be expanded anytime as required. They can fulfill different epistemic requirements, meaning they can be compiled as monolingual parallel text corpora, as comparable bilingual corpora, bilingual translation corpora, etc., whatever the requirements are. And the design criteria are guided by the source text, meaning it is the source text or the topic of the source text which ultimately guides the text to be included in these DIY corpora. There are various possible sources for retrieving corpus text for DIY corpora. The first source would obviously be the client, and in a translation teaching setting, the lecturer can act as client, who provides students with pre-selected corpus texts, which would form part of the corpus use for learning to translate approach, meaning the students do not acquire or improve their own documentation skills here. Then there are specialist resources such as databases, academic articles, etc. The problem here is they're not always available for the required subject matters, and their compilation is quite time-consuming, which would run counter to the in vivo approach of our translation course. And then, of course, there's the internet, which offers a vast amount of information in multiple digital formats. It is highly accessible and therefore the most viable alternative for documenting translation tasks. But the problem is it offers a vast amount of unstructured content and this is also very important, of varying quality. So it would require a rigorous compilation approach if you use the internet as a source of corpus text. Such a compilation approach would consist of 3 phases. Again, I refer to Sanchez-Gijon 2009 here. The first would be you have to determine the characteristics of the resource providing the corpus text. The second is you have to devise specific search strategies to carry out targeted searches. And the third would be you have to establish and apply specific quality criteria. And I will now discuss the 3 phases of this approach in detail. When you talk of the characteristics of the internet as a source of corpus text, what is required is what I like to call an epistemology of Google, Yahoo, or other search engines you use to access the internet. If students are made familiar with the basic characteristics or functioning principles of conventional search engines, they can perform more informed searches. This is the idea behind this epistemology of Google. For example, we could point out the important difference between the surface web and the deep web, with the surface web being that part of the internet which is accessible via conventional search engines, the deep web being the much bigger part of the internet which is not accessible by these search engines. Example of content in the deep web would be password protected websites, content that is provided dynamically or upon request from local databases, or content from a certain hyperlink level downward, which is no longer indexed by conventional search engines. I have here an example of content in the deep web. The entry on the left was generated dynamically from the IATIS database, which would form part of the deep web. The highlighted text string below here, I don't know whether you can see it. You cannot find it if you search for this string in Google, because Google only accesses the surface web, whereas, as I said, this search string was actually drawn from the deep web. The idea behind this epistemology of Google is that students should be made aware that the information they obtain using conventional search engines is by no means all the information that exists on a particular subject, but that more differentiated searches may be necessary. Then you can also point out the difference between universal and vertical search engines. Universal search engines would be Yahoo, Google, et al., which search the entire surface web. Vertical search engines, these are field-specific search engines which cover only a specific subpart of the surface web. For example, websites classified as providing content from the domain of science and technology. There was a good vertical search engine called cirrus.com, which was focused on science and technology. I think it is no longer active, but there may be other examples of these search engines. Also important in this context are the ranking criteria which determine the sorting order of search results. In this context, an important difference is that between the natural listings, which you see here on the left side. These results are listed according to objective ranking algorithms, and here on the right side you have the so-called paid listings. The search engine provider is paid to show these results regardless of any objective ranking criteria. Now, as to these ranking criteria, you could also make your students familiar with one of the most important ranking algorithms, which would be the Google PageRank algorithm, which assigns a numerical weight to different web pages according to the number of hyperlinks to these pages and the page rank of the pages hosting these hyperlinks. This is shown in this graphic here. I won't go into detail, but just students should be aware that there's something working in the background when they're performing their Google or Yahoo searches. I will now move on to phase 2, which covers the issue of devising specific search strategies. The aim is to narrow down the searches to yield only results which are directly relevant to the DIY corpus to be compiled. And conventional search engines such as Google, Yahoo, etc., they offer specific operators you can use for these purposes. For example, the search operator site would restrict the search to specific websites or domains. For example, the string site :deutschebank.de would restrict the search to the Deutsche Bank subcorpus, if you would like to call it this, which is available on the surface web. You can also use something like site.edu, and then you would restrict the search to websites with a top-level domain edu, which are the sites of educational institutions. Search strategies involving this operator may be useful if the students are interested in the terminology or the style employed by a specific client, for example, the corporate language or terminology employed by Deutsche Bank, or if they are looking for high-quality explanatory text on a specific subject matter, which you could probably find on the websites of educational institutions. Then there's also the operator file type, which would restrict the search to documents with a specific file format. For example, file type PDF would restrict the search to PDF files, which, as Zanetti claims, tend to have a more stable content than other file formats. You could also exclude words or websites from your search by placing a dash before the corresponding site or word. Let's say students are looking for text about computer mice and they want to exclude sites dealing with the other primary meaning of this linguistic unit. Then you could devise search strings containing mouse, dash, and then animal, rodent, and so you would exclude websites which deal with mouse as animals. Or if you want to exclude a specific site from the search because prior searches yielded poor quality text, for example, you could devise a search string dash and then name of the site to exclude, for example, dash Wikipedia if you don't trust Wikipedia or whatever. And there are many more options available for specifying web searches in Google. Under support google.com, you can find an exhaustive list of these operators. Now, Zanetti points out that the search strategies I discussed previously, that they're primarily geared towards the compilation of monolingual corpora. So we need additional search strategies if we want to compile bi or multilingual corpora. For example, if you have multilingual websites, you could compare the sitemaps of source and target version in order to identify the category structure of these sites. And if the target language version of the website has the same category structure, which is not always the case, but if it does, it should be fairly easy to locate the corresponding target text, providing it exists, of course. You could also check the URL in the browser bar and see whether there's any ISO language code in there, and you could substitute this with the ISO language code of the target version and see whether there's a target text available. Or the ideal case would be that you have an integrated language selection menu, which you can find on most of the EU websites, for example, but also on the sites of major multilingual or multinational corporations. So, and then there's the issue of establishing and applying quality criteria, which is the final phase of this compilation approach we were talking about. Students must be made aware of possible quality issues involved in corpus compilation, so that they avoid carrying over false or inappropriate solutions they find in the corpus text into their translations. There are two broad approaches to quality control in this context, which would be intra and extra textual quality control. Intra-textual control would cover performing a rough quality assessment of potential corpus text, for example, checking lexis, phraseology, grammar, and depending on the competence level of the students, also genre convention, register requirements, etc. In this case, seriously flawed text such as machine translations without post-editing, they can certainly be spotted and excluded from translations. Less obvious defects such as source language interferences may not be as easy to detect by students because their textual competence will usually not be fully developed yet. So this intertextual approach could be complemented by an extra-textual approach to quality control, which would involve developing a list of extra-textual quality criteria, for example, authorship or publishing organization, although we all know that this is no guarantee for high quality of the text you find there. But you should then apply these criteria using the search strategies described previously. For example, you could use the operator site to restrict the search to a priori to specific websites or to specific top-level domains which are likely to fulfill your quality requirements. Or you could also use a dash to exclude websites where you think the quality of the text is not high enough for the text to be included in your corpus. Instead of using the internet as a source of corpus text, there's also the possibility to use the internet itself as a macro corpus, which can be queried directly for linguistic or conceptual information related to specific translation tasks. In this case, there's no indication of the external boundaries or the internal subdivision of the internet macro corpus. The focus shifts here from the corpus design and compilation to specific search strategies and the interpretation of these results. It would involve using search strategies, the strategies we discussed previously, together with some more linguistically oriented search functions. First, the focus will now be on querying the internet using conventional search engines. For example, students could use wildcard characters in their searches. Let's say they're faced with a source text element to issue shares, and students know that the German equivalent of shares is Aktien, but they're unsure about the required collocate. Is it Aktien veröffentlichen, herausgeben, begeben, etc. Now, they could devise a search string containing the wildcard for the unknown verb. For example, die von dem Unternehmen, then the wildcard Aktien, and just see what Google offers them. And you can see from the screenshot here that die von dem Unternehmen ausgegebenen Aktien is found twice. You could check whether it comes from a high quality source, and then you could check the word group Aktien ausgeben. You could check whether you find this word group, for example, on the sites of major publicly listed companies in Germany, and this would be an indication that this is indeed the required collocate. You could also query the internet for explanatory context for specific concepts by using the search operator define. For example, if you use the search string, am I right here? Yeah. if you use a search string such as defined frequency converter, you get a list of internet definitions of the search term frequency converter together with hyperlinks to the corresponding web pages. Or you could formulate search strings in the form of a definition and then leave the definitions unspecified. For example, if you're looking for a definition, your search string would be a piston ring is, if you're looking for piston rings. If you're looking for hyponymic information, you could devise a search string. A piston ring is a kind of, or types of piston rings are. If you're looking for functional information, you could use a piston ring is used to, for example, or if you're looking for meronymic or holonymic information, a piston ring consists of, contains, is part of, etc. Well, some creativity may be in order here to find the information you need for your translation task. Then there's the possibility of using querying the internet using specific web concordances. Zanetin points out that conventional search engines, they do not present the results in formats suitable for linguistic analysis. For example, you cannot manipulate the results by sorting them for concordance lines, generating collocation lists, etc. And there are specific web concordances which address these shortcomings, and they offer functions which are tailored to the linguistic analysis of the results. I will focus here on WebCorp Live, as this is the most widely used of these web concordances. WebCorp Live consists of the use of WebCorp Live consists of two phases. The first would be a search phase, where you specify the various search parameters, for example, the search engine to use, Google, Bing, etc., the language of the web pages to search, the number of concordance lines, and so on, and several options which are provided by conventional search engines, such as the specification of a particular site to search, or the use of wildcard characters in the search string. They're also available in WebCorp Live, so you could employ some of the strategies discussed previously when using this web concordancer. Here's what the result presentation in WebCorp Live looks like without post-processing, which would be the second phase. The result compilation takes between 30 to 50 seconds, depending on the number of parameters you specify in the search phase, which may or may not be quite long, depending on your actual translation context. But you see here in this list, I searched for convertible bonds. You find the information that these are hybrid securities, are issued by corporations. They're tied to shares of common stock, are hybrid fixed income securities, and this already gives you a broad idea of what you would be dealing with here in this context. The second phase would be a post-processing phase, where you can specify the number of words or characters to display to the left and right of the search term. You can sort the concordances by date or alphabetically, and you can generate a table with the most frequent collocates, and you can specify stop words to exclude from the list. For example, frequently used words such as a and the. And this is what the result presentation would look like after post-processing. I sorted by words to the right and generated a collocate list excluding stop words, and the list, you can see it here. The search results, they are caged for 7 days. And the hyperlink to the caged results can be shared with other researchers, students, or translators. And I think, if I'm not mistaken, that's it. Thank you very much for your attention.